Hello pre-calculus students, and welcome to part 2 of a video on piecewise defined linear functions. So we're looking at lines here. Sorry about that, we're looking at lines. And let's go on. We've already done a couple of examples of piecewise defined linear functions. Now we're going to look at another one. So here's another piecewise defined linear function, and this one is going to end up being something else in addition to a piecewise defined linear function, as we'll see in a minute. So given the piecewise defined function h of x equals the opposite of x plus 4 for this interval and positive x plus 4 for this interval, we're going to find each value in a through d. Okay, so let's just kind of think of how to use that function too. We're just evaluating for different values of this function. This, by the way, I can see a typo here because this is h and these are f, so why don't we just call this f so that they're all consistent, they're all the same. Okay, so let's just make that correction. So f of negative 5, first decide, is it the upper or the lower? Negative 5 is less than negative 4, so I'm going to use the upper. So I'm going to go the opposite of negative 5 plus 4, which is the opposite of negative 1, which is 1. So there's the point, negative 5, 1. All right, let's do negative 4. So negative 4 is not in this one because it doesn't include the negative 4, so we're going to have to use the other rule. So this is going to be the bottom one, which is negative 4 plus 4, or 0. Okay, let's find f of negative 3. I'll let you think about it for a minute, and I'm going to pause the video, and you're going to find f of negative 3. Okay, so you can see you've got to be careful here because sometimes people look at a negative 3 and they say that's less than negative 4, but really negative 3 is greater than negative 4. So we have to use this one. So it's going to just be negative 3 plus 4, positive 1. Okay, and then we get, for similar reasons, we get positive 4 here. All right, name the function rule when x is less than negative 4. Well, this is the domain, and the function rule there would be f of x is equal to the opposite of x plus 4. When x is greater than or equal to negative 4, name the function rule. Okay. There we go. So now let's graph the function. So we're going to graph it just like we graphed the last one. I'm just going to rewrite this left piece first as negative x minus 4 so we can graph it in slope-intercept form. Let me zoom in on this so we can see clearly what we're doing. So we have a y-intercept of negative 4. We have a x with a slope of negative 1. So we have here, here. Let's plot that one. And this is going to be cool what happens here. It might surprise some of you, so let's see what happens. We only want this when x is less than negative 4, so I'm looking at it. Here's the negative 4. I only want it to the left of that, so I only want this thing right here. And that is a hole at negative 4, 0. We can check that by finding f of negative 4, this is a hole, and we get the opposite of negative 4 plus 4, which is 0. Okay? Let's do the other piece. Y-intercept of positive 4, way up here. Okay? Slope of positive 1. Up 1 over 1, here, here, down here. Let's graph the line. Uh-oh, this one looks like it goes right into that hole. And actually, I can't avoid it. It's going to go right into that hole. All right, let's see what happens here. I only want to keep the stuff where x is greater than or equal to negative 4. So here, I want the point at f of negative 4, which is 0. So that means this negative 4, 0, which was a hole for the left piece, is a point for the right piece. It's a point. Okay, this function does have a point. It had a hole, but now it filled it in, so the point is there. And the point now, not the hole, but the point is negative 4, 0. We want everything that is greater than or equal to negative 4, so I'm going to count this stuff over here, and let's just highlight it. And then I'm going to ask you guys, what does this graph look like? What does it look like? Okay, well the answer to the question is h, right there. They kind of give it away in the notes. I gave it away in the notes. Write the function as an absolute value function. It looks like, and it is, an absolute value function. So let's see if we can write that equation. That's just an absolute value function. It's translated to the left 4 units. So that's going to be f of x equals absolute value of x plus 4. That's how you show something that's moved to the left, right? It moves to the left, it's a plus in there. What's the output of this function? What's the output? What is the output when the input is negative 4? So let's find now the absolute value function of negative 4. And what do we get? We get negative 4, absolute value of negative 4 plus 4, 0. The output is 0. Does that make sense for our graph? It sure does. Okay, we've actually found another way of thinking about the absolute value. Okay, so let's pause it and turn the page and do the last part. Okay, so now we're just looking at the basic absolute value function, and I want you to just think for a minute, what does this mean? What does the absolute value mean? Well, it means if the input is already a positive number, the output doesn't change, right? Because this only takes negatives and changes them. It takes positives, doesn't do anything to them, right? It's already positive, it stays positive. So what this is this a function that whenever, and I'm going to write this as a piecewise so you can use these fancy brackets. So whenever, and I'll put the domain first, whenever x is already greater than or equal to 0, it doesn't do a thing to the function. It just keeps it the same. So we have x. If you put in a negative number here, like let's say you have f of negative 3, then what that does is takes the absolute value of negative 3 and it takes that input and it goes to the exact opposite of the negative, which is a positive. So when you take the absolute value of a negative number, your output is the opposite of what you started with, from negative to positive. So this is the opposite of what you started with, but only if you started with something that was negative. Okay? That absolute value and that piecewise function are exactly the same thing. In fact, if you had algebra before you learned what the meaning of those bars were, this is how we would teach you what the absolute value means. We didn't have a way of writing it down then without the algebra. This is it. Okay, let's try the same thing for another example. Let's see if we can write this as a piecewise defined function. So we're going to basically do the same thing. What we're going to do is think about this stuff on the inside here stayed the same when it was positive, and it changed when it was negative. So here, this stuff on the inside will stay the same as long as it is positive. So this is true as long as it, x minus 1, is greater than or equal to 0. Oops, sorry about that. Okay, so again, this will stay the same as long as this is positive. So this will stay the same as long as it's positive. So in other words, as long as x is greater than or equal to 1. All right, it will be the opposite whenever this is negative. So it will be the opposite of x minus 1 whenever x minus 1 is less than 0. In other words, whenever x is less than 1. Okay, that's it. That's the piecewise defined function that's identical to this absolute value. If you graph this function and you graph this function, you're going to see the exact same thing. So we can simplify this a little bit because this is not the prettiest way to keep it. So f of x is equal to x minus 1 whenever x is greater than or equal to 1, and negative x plus 1 whenever x is less than 1. That piecewise function is the same as that absolute value function. Okay, let's look at an example of something different now, just taking a piecewise defined linear function and pulling out the equations. So we're going to write a definition for this one. All right, so this is the equation. Since it's horizontal, this is the equation y equals 3, or f of x equals 3. This one, we need to write this equation carefully here. So this has a y-intercept of 0. We could choose a lot of ways to do this. I'm going to just choose point-slope form, I guess, as good as any. So I need the slope. So the slope of this would be negative 1 minus 0 over 1 minus 0, which is negative 1 over 1. So the slope is negative 1. And I'm going to choose, how about that point? Okay, so I have y minus 0 equals negative 1 times x minus 0. So my linear equation there is just y equals negative x. That's all that is. Okay, so now our piecewise defined function has to have both of these. So we're going to have, we'll just call it f of x. Okay, and one piece, let's put both pieces here. One piece is 3. That's the f of x equals 3. And that is true whenever x is less than or equal to 0. And it's negative x whenever x is between 0 and 1, but not including 0 and including 1. So we have to know how to write that. So again, more practice with inequalities for some of you, but x between 0 and 1, and x is greater than 0 and less than or equal to 1. And so there's the piecewise defined function that represents the graph. Okay, I hope you found this video helpful.